Today we're going to discuss rule-based intrusion detection. Rule-based techniques detects intrusion by observing events in the system and applying a set of rules that lead to a decision regarding whether a given pattern of activity is or is not suspicious. First, we'll discuss rule-based anomaly detection. This is very similar in terms of its approach and strengths to statistical anomaly detection. Historical audit records are analyzed to identify usage patterns and to generate automatically rules that describes those patterns. Rules may represent past behavior patterns of users, programs, privileges, time slots, terminals, and so on. Current behavior is then observed and each transaction is matched against a set of rules to determine if it is conforms to any historically observed pattern of behavior. As with the statistical anomaly detection, rule-based anomaly detection does not require knowledge of security vulnerabilities within the system. Rule-based penetration identification. This will takes a very different approach to intrusion detection. The key feature of such system is the use of rules for identifying known penetrations or penetrations that would exploit known weakness. Rules can also be defined that identify suspicious behavior even when the behavior is within the bounds of established pattern of usage. The most fruitful approach to developing such rules is to analyze attack tools and scripts collected on the internet. Next it is base rate fallacy. An intrusion detection system should detect a substantial percentage of intrusions while keeping the false alarm rate at an acceptable level. If the system frequently triggers an alert when there is no intrusion, then either system managers will begin to ignore the alarms or much time will be wasted analyzing the false alarms. Nature of the probabilities involved. It is very difficult to meet the standard of high rate of detections with a low rate of false alarms. A study of existing intrusion detection systems that will be indicate that current systems have not overcome the problem of the base rate fallacy. Distributed intrusion detection. The organization, however, needs to defend a distributed collection of code that will be supported by local area network or inter-network. Although it is possible to mount a defense by using stand-alone intrusion detection system on each host, a more effective defense can be achieved by coordination and cooperation among intrusion detection systems across the network. There will be following major issues in the design of a distributed intrusion detection system. First one is a distributed intrusion detection system may need to deal with different audit record formats. Different systems will employ different native audit collection systems, and if using intrusion detection may employ different formats for security related audit records. One or more nodes in the network will serve as collection and analysis points for the data from the systems on the network. Third point is either a centralized or decentralized architecture can be used. With a centralized architecture, there is a single center point of collection and analysis of all the audit data. Next one is called distributed intrusion detection architecture that you can show in the diagram. This is for example of distributed intrusion detection system. This was developed at the University of California. This diagram will show the overall architecture. It will consist of three main components. One is called as a host agent module, an audit collection module operating as a background process on a monitored system. Its purpose is to collect the data on security related events on the host and transmit these to the central manager. Local area network monitor agent module. This will operate in the same fashion as a host agent module, except that it analyzes local area network traffic and reports the results to the central manager. Central manager module. This will receive the reports from the local area network monitor and host agents and process and correlates these reports to detect intrusion. This diagram will explain the agent architecture. This will consist of a filter, logic, central manager, agent protocol machine, and also templates. The agent captures each audit record produced by the native audit collection system. A filter is applied that retains only those records that are of security interest. These records are then reformatted into a standard format referred to as the host audit record. Next, a template-driven logic model analyzes the records for suspicious activity. The agent will be scans for notable events that are of interest independent of any past events. For example, failed file access, accessing system files, and changing a file access control. In the next higher level, the agent looks for sequence of events such as known attack patterns. Finally, the agent looks for anomalous behavior of an individual user based on historical profile of that user, such as number of programs executed, number of files accessed, and the like. When the suspicious activity is detected, an alarm will be sent to the central manager. Then central manager will include an expert system that can draw inferences from received data. The manager may also query individual systems for copies of chairs to correlate with those from other agents. The local area network monitor agent also supplies information to the central manager. The local area network monitor agent audits host-based connections, services used, and volume of traffic. It searches for significant events such as sudden changes in a network load, the use of security related services and network activities such as or login. Honeypots, a relatively recent innovation in intrusion detection technology is the honeypot. Honeypots are decoy systems that are designed to lure a potential attacker away from critical systems. Honeypots are designed to divert an attacker from access in critical systems, collect the information about the attacker's activity, encourage the attacker to stay on the system long enough for administrators to respond. These systems are filled with fabricated information designed to appear valuable but that a estimated user of the system would not access. Password management. First, we'll discuss password protection. How we'll be protecting our password. The front line of defense against intruders is the password system. The all multi-user systems require that a user provide not only a name or identifier but also a password. The password serves to authenticate the ID of the individual logging at the system. In fact, this ID it provides security in the following ways. First one is the ID will determine whether the user is authorized to gain access to the system. Second one is the ID determines the privileges accorded to the user. A few users may have supervisory or super user status that enables them to read files and perform functions that are especially protected by the operating system. Third point is the ID can be used in what is referred to as a discretionary access control. The vulnerability of passwords. To understand the nature of the threat to the password-based system, we'll consider widely used operating system Unix, in which passwords are never stored in the clear. Rather, the following procedure is employed. Each user selects a password up to 8 printable characters in length. This will be converted into 56-bit value that serves as the key input to an encryption routine. The hashed password is then stored together with a plain text copy of the salt in the password file for the corresponding user ID. The salt serves two purposes. First one is it prevents duplicate password from being visible in the password file. Second one is it effectively increases the length of the password without requiring the user to remember two additional characters. Third one is it prevents the use of hardware implementation of DES which would use the difficulty of a brute force guessing attack. Managing password, that you have to give the education, that means what is the strong password that should contain maximum of 6 letters, and you have to mix up with the uppercase and the lowercase letters number, okay, and also other characters, and you have to give the guidance to create a strong password. Thank you.